This is the Hallicrafters Model S-40. It was made by the Hallicrafters Company in Chicago, Illinois, back around the 1946-47 era. But as you can see, this is being fixed up a little bit, you could say. I bought this as a renovation project. The front panel and all the decals or decals were in bad shape, and I had no idea whether or not the radio actually worked. So I took it home, took the cabinet apart, didn't sandblast, I hand sanded it down and repainted it with this, it's probably not the original color for the S-40, which was more of a dusty green. This is called a hunter green, but it was the closest I could find in modern aerosol paints. And also bought the decals or decal set from a company called Radio Days in New York State, I believe. And which is amazing that you can get those sorts of markings for a radio this old, and they probably don't sell a lot of those kits. I wouldn't imagine a lot of these radios are around anymore. But also I got a new clear window for the main dial. I think the band spread dial was okay. So nice thing about this radio is it has this tilting lid that allows you access to the tubes. As you can see on the photo here, it's on the left side is the tuning capacitor, so you can easily clean that. In the middle are the IF cans, and scattered throughout are the various tubes, and they're all marked with their part numbers, or the tube numbers. So it's a fairly easy radio to maintain from that standpoint. In terms of frequency coverage, it covers from about 550 kilohertz, which is the bottom end of the medium wave band, and that goes up to about 1.5 kilohertz or megahertz, or 1500 kilohertz. And then at the top end, this thing goes up to about 44 megahertz on the top scale. So I think that just happened to work out that way. I think it's basically intended as an HF receiver. That band from 30 to 50 megahertz is the old VHF FM band, which is hardly used anymore, and I don't think this receiver was intended necessarily to, unless they were using AM in those days, necessarily to be useful up in that range. So it is, it's in 4 bands. As I say, the bottom one is medium wave. Then it goes from 1.7 megahertz on the next scale up to 5 megahertz. And on the next scale, it goes from about 5.5 megahertz. I have to keep wheeling it around to see what the actual frequencies are, up to about 15, so about 6 to 15 megahertz. And as I say, that top scale goes up to 44 megahertz and down around the 16 megahertz range. So just taking a closer look at the controls now, you have on the left a sensitivity control, which is really the same as what we call an RF gain control nowadays. Next is the band switch. As I mentioned, there are 4 bands, and try to do this without covering up your view. 1, 2, 3, and 4. It's good stiff control. And then the volume control, of course. And another control here called AVC. Now, they used to call it automatic volume control. I think even up to the 1960s, a lot of radios have that designation. That's the same as what we tend to call automatic gain control, or AGC nowadays. Just to show you, I'm on a local radio station. I've got the sensitivity turned back. And this sensitivity control is actually almost like an on-off switch. There is a little bit of range at the top where you're actually controlling the RF gain, but once you get below a certain point, the radio really goes deaf. So by taking the sensitivity or gain to the top, I've actually got the volume control backed right off here. This is how strong this local station is. So sometimes you might want to just use the sensitivity control as a volume control when you got strong stations. But I'll show you something else, this AVC switch. If I turn it off, I don't know if you can hear that.
Allows us to bear witness and know yes.
The radio is actually overloading. So it's probably a good idea for the most part to keep the AVC on. And it's
he developed it
nice and clean now. So we'll turn that back for the moment. And of course up here is the main tuning dial, which rotates the main dial up above. Moving to the right on the front panel, we have a CW and AM switch here. Now, this is I'll demonstrate this a little later when we have some good signals on the radio. But it's a very crude method of getting single sideband or CW. Most of the time, it's so unstable that I wouldn't use it on any of the higher bands. I would just use it on probably the scale number 2, which goes from, what did I say, 1.7 to 6 megahertz or something like that. Above that, the radio is not stable enough really to use this properly. And once you turn that on and you kind of, roughly tune in either with the band spread or the main tuning to a sideband station, then you can go over to this pitch control. And this is actually like a slug that moves in and out of a coil. That's what it's actually controlling. And it helps a bit. But again, the whole radio is not really stable enough to really be used reliably for single sideband, although I found it usable on both 160 and 80 meters ham bands. So yeah, the band spread dial is for, you can't see it on screen at the moment, but it's for that small dial, which really helps because again, this is not a stable receiver. So this band spread really helps you tune much more slowly into various stations. This switch is used, it's strange, but it's the tone control and it's used to power the radio on and off. Oh, I skipped one down here, we'll get back to that. But it does work, it gives you high, medium, and low tones. So if you've got a radio station that sounds particularly scratchy or squeaky, just turn it down to low or medium, but most of the time I leave it on high. So down here we have a noise limiter, and I find on the medium wave or AM band, I do get quite a bit of kind of pulse or ignition type noise around here. And I did find that it's actually is an fairly effective noise limiter. I find noise limiters on shortwave radios in general don't really do much. It's pretty well designed for, getting rid of ignition noise and things like that. And with modern cars, you don't tend to hear that as much. And finally, over to the extreme right, we've got a standby receive switch. And this would have been used probably in a scenario where this receiver was used in a ham radio setup, where you had a transmitter, and every time you transmitted, what you would do, and I'll turn up the volume here.
More Ferris is passing 10 times more.
It just kills the front. I think it kills the front end of the radio so that it doesn't get blasted by the transmitter. Anyway, that's we have a headphone jack, and that's it. And a nice big speaker. It's actually quite nice sounding speaker. Again, I had to do a repaint with some silver paint on this. And so luckily it came up very, very well. Just a close-up of the main dial now. As you can see, there's the medium wave scale, which I'll just turn back there, medium wave, and then this scale that goes from 1.7 up to 5 megahertz. This one that goes from 6 to 15, and the other one that goes from about, I think, 16 up to about 44 megahertz. And it has the amateur band markings on it. Now, I'm going to talk about difficulty of dealing with these older radios. Unless you totally replace a lot of the components like capacitors, which I have not done, so that's my bad. I've only changed a few that looked a little dodgy. What happens is this thing becomes very hard to align. And I do have alignment procedures for it, which I followed to the letter. But what I found was that tracking, which basically, let's say we have signal generator set up at 15 megahertz here. If I get that tuned in properly, as they say in the instructions, using a trimmer capacitor on that local oscillator, and then I go down to the bottom of that same band, and let's say, well, actually, they recommend 6 megahertz. So if I set the signal generator to 6 megahertz now, I find that it's somewhere way down here. And that's called tracking. And they do have on the bottom, underneath the front panel, there's some holes. And you can get at these tracking capacitors or trimmers for each of the bands. But no matter what I did, I could not get the tracking to work properly, nor could I get the local oscillator to, when the dial was properly set up. You can see there's some markings here that this pointer is supposed to be lined up with. I had to undo the set screw for that dial and rotate it a bit in order to get this to tune up to the high end of the band. So that again might mean recapping the entire radio as much as possible. So unfortunately that means that this dial is not lined up properly with its markings, but it is functional. But the problem is, this probably goes back to the tracking idea, components probably need to be changed in order to get this to tune properly. And even if I got 15 megahertz lined up, if I went down to 10 megahertz WWV, it would probably be actually a little high. Whereas when I go down here to 6 megahertz, I might have to tune down lower. So that's the main dial. And finally, the last feature is the actual band spread dial. And this is just, this goes from 0 up to 100, and I couldn't tell you offhand what the increments represent in terms of frequency change. I found when I got this, and again, the way the Hallicrafters manual said that the dial string should be placed on this, it was actually, you would actually be going down in frequency as you went up from 0. And I found that counterintuitive, so I spun it around. So now it goes, 0 is wherever you've tuned the main dial to, and then you go up from there. So this, again, it's feeling nice. It's a nice weighted sort of control. So it was probably a very quality radio in its day. But again, you know, radios in that era were not the hottest receivers, not the most stable receivers. We're kind of spoiled by what we've got today. We're now tuned to the top band here, and as you can see, I know the dial is off a little bit, but hopefully you can hear WWV. So we know this receiver works fine on the top band. In fact, let's go up and in the area of CB band. It's definitely working on that part of the band. Unfortunately, I haven't been able to... there's FT8 on 10 meters. I was going to say, unfortunately, I haven't been able to actually hear anything on 10 meters. There it is. We'll try the CW function. I'm not actually hearing any single sideband up there at the moment. So this is daytime listening, and it apparently is working fairly well on the top band.
Your muddy waters in the swamp I just got down.
Okay, it's now evening, and we're getting some single sideband action here on 80 meters on the second scale, and I'm using the pitch control to
Hey Larry, why are you so loud?
fine-tune these guys in.
Oh my gosh, it seems like you have both amplifiers in parallel, Larry.
So it's actually usable down on the lower bands, but on the higher scales, it's the radio's too unstable to use the CW mode. As you can hear, we're on this band, third band, around 10 megahertz. That's WWV. And as we tune down through, what is it, the 29 meter band? Plenty of stations in there. So the receiver is usable, even though it's got some alignment faults at present. So if you found this video interesting, informative, maybe this is the first time you've seen this radio, maybe this is a bit of nostalgia for you. Either way, please leave some comments below. I'd love to hear about your experiences with this radio. And don't forget to like, if you did like this video, like, and consider subscribing to the channel as well. And we'll see you in the next one.